For section 2.6, we're going to transform linear functions. And this first picture here I have for you is showing how to rewrite your equations, your functions, if you have a translation or if you have a reflection. So there's a couple different translations. One's horizontal, so if you're moving it left or right, you are going to add or subtract numbers from the x value. And I want you to notice that right here, if h is greater than 0, it moves it to the right. And if h is less than 0, it moves it to the left. So, and that is being added or subtracted from the x value. Moving over to the vertical shift, which is up or down, you're going to add on to the end of your function, add or subtract. Add will move it up, subtracting will move it down. And then the reflection across the y-axis, if you're going to flip it over the y-axis, then your x just becomes negative. If you're going to flip it across the x-axis, then your whole function becomes negative or opposite. So that chart will be handy to you for your assignment and your upcoming test. So for example 1, let g of x be the indicated transformation of f of x. Write the rule for g of x. So for part A, we have f of x equals 2x plus 3, and we're going to have a vertical translation 4 units up. So if we go back to our chart, up is vertical, and we're going to go 4 up, and if k is greater than 0, we're going to move up. So we're going to have to add 4 to our equation. So we're going to have g of x equals 2x plus 3, and then we have to add 4 onto the end of that. So to simplify that, we have g of x equals 2x plus 7. So that is our new equation after the translation 4 units up. For part B, we have to take the linear function defined in the table and reflect it across the y-axis. So before we can do anything, we have to figure out what the function is. First thing I notice is that we are given the point 0, 2. So that is our y-intercept. So if we had the formula f of x equals mx plus b, 2 is going to be our y-intercept, positive 2. So the only other thing that we need here is the slope. So I'm going to take the first 2 points and figure out the slope. So y2 minus y1 over x2 minus x1. So 2 minus 0 is 2. 0 minus negative 1 is 0 plus 1, so that would be 1. 2 over 1 simplifies to 2. So our slope is 2. So the equation for this line is f of x equals 2x plus 2. And we have to reflect it across the y-axis. So if I go back to my table, reflecting it across the y-axis is simply right here, it says make x negative. So I will have g of x equals 2, and then x will be negative plus 2. So to simplify that, to make it look correct, 2 times the negative x is really negative 2x plus 2. We write that negative sign out front of the coefficient there. And then this one, we have f of x equals, somehow I missed the equal sign, 3x plus 1, and we're going to translate that 2 units to the right. And if we look up here, translating to the right is going to be a horizontal shift. So the formula says we have to do x minus h. H greater than 0 moves to the right. So we're moving 2 units to the right. So we're going to plug a 2 in there where that h is. So we're actually going to have x minus 2 in our formula because this is telling us we have to minus whatever that h is. So if I go back here, I'm going to have g of x equals 3 and then x minus 2 is what the chart showed us, plus 1. And that would be our equation for the new line. Now you could distribute the 3 and simplify down, but it's okay to leave it like this for now. Then we're going to look at stretches and compressions. So horizontal and vertical. And if it's a horizontal stretch or compression by a factor of b, and a b is greater than 1, it's going to stretch away from the y. And if the absolute value of b is between 0 and 1, it's going to compress towards the y-axis. So it's going to be shrunk or squeezed toward the y-axis. And we are going to multiply x by 1 over b for that horizontal change. If it's a vertical change, then we're going to multiply whatever our factor is by our entire function. So if it's a vertical stretch and the factor is 2, we're going to take 2 and multiply our whole function by that. So a is greater than 1 is going to stretch it away from the x. And if the absolute value of a is between 0 and 1, it's going to compress or squeeze towards the x-axis. So for example 2, we're going to let g of x be a horizontal compression of f of x equals 2x minus 1 by a factor of 1/3. Write the rule for g of x and then graph our function. So it's a horizontal compression. And so we're going to use this over here. And we are going to have to multiply the x by our scale factor. So we are going to have to do, we have the 2, and then right in front of the x, we're going to have to multiply the x by 1 over the scale factor, which is 1/3. And then we have x minus 1. So we have to simplify that. 1 divided by 1/3, so that's division with fractions. Keep, change, flip, keep your 1, change to multiplication, and flip the 1/3. So that would become 3 over 1, which is 3. So you would have 1 times 3. So this is really 2 times 3x minus 1. And then 2 times 3 is 6, so 6x minus 1. And our new function is called g of x, so we have to have that out front. So that would be our function, and then we have to graph that. So our y-intercept is -1. That minus 1 at the end tells us that, and our slope is 6, so we're going to go up 6 and over 1 to graph our g of x. And then if you wanted to see the change, we can graph the f of x. The y-intercept is -1, so it is also right there. But our slope is 2, so we go up 2 and over 1. So there would be our starting function, f of x. For example 3, we're going to have a vertical shift of f of x equals x down 2 units. Not quite sure why it changed all my equal signs when I uploaded it to Cami here. Down 2 units followed by a vertical stretch of 5, and then we're going to write the rule for g of x. So if we're moving it down 2 units, we're just going to subtract 2. So up or down is pretty simple. You add or subtract onto the end. So we would have g of x equals x minus 2. That would take care of this sliding it down. But then we're going to have a vertical stretch of a factor of 5. So if you go back up here, vertical stretch, we have to multiply the whole function by our factor, which is 5. Oops. So we're going to have g of x, and we're going to multiply all of that by 5. distribute that 5. So g of x equals 5x minus 10. For example, 4, the dance club is selling beaded purses as a fundraiser. The function r of n equals 12.5n represents the club's revenue in dollars, where n is the number of purses sold. So they're going to make $12.50 for each purse they sell. The club paid $75 for the materials needed to make the purses. Write a new function, p of n, for the club's profit. So the profit, the function for the profit is they're going to make 12.5 for every purse, but they've already paid $75. So they have to take that $75 out of their profit to pay for the materials that they needed. And then graph this. I've already done this on Desmos calculator. I did the red is 12.5n, that's our f of x, and the blue is our g of x. So you can see the two different functions there. And then we have to describe the transformation that has been applied. So if you look at the difference here, the only difference is this negative 75 or minus 75 was put onto the other, the 12.5n that we started with. So when it's just put onto the end like that, it's a translation. And it was minus 75. So that means it went down 75. So if you picked a point here, let's say this origin point here, and you went down 75, that's where the blue line will cross the y-axis. And I have it zoomed in too far for you to see that, but that red line is really slid down to the blue line, 75 units.